Hey everybody, Mr. Bucko here with the Bridges of Konigsberg problem that we did in class. So I know that some of you are gone and missed it and maybe want to see it again. And it's about graph theory and a network of nodes and the arcs that connect them. So I'm going to do this problem here and answer a couple questions about that. So here we go. We have a network here that has 4 nodes, and each of the nodes are each of the islands, or you'll mostly see it as dots when you see it in practice. But we have 4 nodes here. We have Nelson World, Bucko Land, Bowser's Castle, and Fireball Island. And each of those nodes have arcs coming out of them, and the arcs in this case are the bridges from each of the lands or nodes, however you want to say that. So Nelson World here has 1, 2, 3 arcs coming out, or to Nelson World, however you want to view that. It doesn't really matter. So I'm going to make a note here that Nelson World has 3 arcs, or bridges, coming out of it in this case. So I'll make a note of that there. I'll get rid of these stars here, so we'll move on to the next one. The next one I'll go over to Bucko Land here. Bucko Land's another node, or a dot, or in this case it's an island in this problem. And I'm going to count how many arcs are coming out of that node. And that one, similarly, has 1 right here, 2, 3. 3 nodes, or 3 arcs, I'm sorry, coming out of Bucko Land, out of this node here. So I will make a note of that there are 3 arcs coming from that one. And then I'll move on to the next one, get rid of these stars, and I will see that Bowser's Castle here has 1, 2, 3. Make a note of those. There's 1 here, 2 here, 3 here. 3 arcs from the node of Bowser's Castle. So we'll make a note of that right here, also 3. Get rid of these, and we'll move on to the last node, which is Fireball Island here in the middle, and we'll count the amount of arcs coming from or going to Fireball Island. 1, 2, 3, 4, 5. There are 5 arcs coming from or going to Fireball Island. Make a note of that here. Get rid of these stars. And now we have all our nodes labeled. All our nodes are labeled with how many arcs are coming to or going from them. Euler says that if there are more than 2 odd nodes, the network is not traversable. And as we see here, Fireball Island has 5, Nelson World has 3, Bucko Land has 3, Bowser's Castle has 3. I'm looking at this screen and I'm seeing 4 odd numbers. And when there are more than 2 odd numbers, that means the network is not traversable. We cannot start somewhere, go over the bridges, and cover all the bridges only once, and end somewhere where we have been stuck and have covered all the bridges. So this network is not traversable because I'm looking at the screen. I see more than 2 odd numbers. If I saw 2, that would be okay. If I saw 1, that's okay. If I saw 0 odd numbers, that's okay. One of the questions asks, what if you add a bridge? Could you add a bridge here and make this network traversable? And we'll do that, and I'll actually do that real quick. With a line here, suppose I'll just take this right here and make this a bridge. So now this red line is a bridge from Nelson World to Bowser's Castle. If I change this now, I look at this node of Nelson World now has 1, 2, 3, 4 bridges. So now this will be a 4. Change this to a 4 here. And similarly, Bowser's Castle now has 1, 2, 3, 4 arcs, or bridges, coming out of it as well. So if that red line is a bridge, now if I ask you if this network is traversable, the answer is yes, because Bowser's Castle has 4, Nelson World has 4, Fireball Island 5, Bucko Land 3. Now there are only 2 odd numbers. So this would be a traversable network if I added a bridge here.